Swayam Prabha. Digital India. Educated India.
So this S bar is a very innovative introduction into the grammatical of the language. So this contribution came from the generative grammar, mainly due to a very famous linguist called Noam Chomsky, who used to teach in MIT. And I had the good fortune of doing 2 courses with him, Introduction to Linguistics and Advanced Linguistics. So he has a huge amount of work on linguistics, and the modern linguistics is really built on the work of Noam Chomsky. There are of course a lot of opposing theories. India had a tremendous linguistic tradition in the form of Panini and that tradition. Now Panini's tradition and Chomsky's tradition, they are two competing traditions, and there are important differences which we would like to look at as we go ahead. And in both traditions, of course, we can take a data-driven approach to make decisions at different points in the sentence, at different positions in the sentence, which is the NLP task. Now, S bar is used in complex sentences. Complex sentences have clauses, and they normally start with a WH word. And S is used for normal sentences. So the difference between S bar and S is this. S bar is contribution from generative grammar. S bar is used for complex sentences. Complex sentences have clauses. They start with WH word, and S is used for normal sentences. So if I look at the sentence again, the cameraman shot the batsman when he was near the minister. The sentence S, the cameraman shot the batsman when he was near the minister. S bar is when he was near the minister, and S is he was near the minister. So S bar contains when plus a simple sentence, he was near the minister. Okay, this is how S bar is built. Remember that S bar has a simple sentence within it. Now compare this with a sentence, I know the boy who lives in Delhi. I know the boy who lives in Delhi. This also has a clause, who lives in Delhi. Okay, so the sentence S is NP VP. NP is I, VP is know the boy who lives in Delhi, VP is know, and NP is the boy. Now NP has a structure WHNP. So this who is given the label WHNP. This is to show that it is introducing a phrase or a sentence within the NP. And then there is an S. Okay. So that S is consisting of only VP. So we are dealing with only a verb phrase, lives in Delhi. You can have sentences without the noun phrase. Go there, for example. Go there is an imperative sentence. It has only verb phrase. So this VP is VBZ lives and PP in Delhi. So lives in Delhi. Okay. So if you want to be very correct, okay, very correct, then lives in Delhi is a VP. Of course, it is. It is not preceded by NP. So this particular sentence, which consists of only VP, is different from a sentence go there. Go there is a complete sentence, but lives in Delhi is not a complete sentence. So you can again introduce a special symbol here. You may call it, S prime or something, or S tilde, saying that it is a special kind of sentence without NP. Okay, but still look at the structure. I know the boy who lives in Delhi. So this is I, NP, and the whole thing, know the boy who lives in Delhi, is a verb phrase. That verb phrase consists of a verb know and a noun phrase, the boy who lives in Delhi. So that's a complete complex noun phrase which has its own internal structure. And the boy who lives in Delhi has this structure, WHNP, Okay, the the boy who lives in Delhi, yes, and lives in Delhi uh, is a verb phrase which actually is a sentence by itself and is preceded by a WHNP. Okay, so the boy who lives in Delhi is a complete structure. Now, in this situation, we need to be clear about different types of sentences. Simple sentence, the cameraman shot the batsman. Complex sentence, the cameraman shot the batsman when he was near the minister, introduces a clause. Compound sentence, the cameraman shot the batsman and he was happy. Again, it is not clear who was happy, the batsman or the cameraman. Okay, but one thing we can be sure is that here the meaning of shot is not firing with a gun. Okay, most likely not firing with a gun. This is where the language ambiguity comes into play. So this is a slightly deeper look at how sentences are constructed and how parsing needs to be done. Now look at all the decisions that we took. Okay, uh, when he was near the minister, we needed to decide this: when he was near the minister should be attached to batsman or shot. Okay, depending on the meaning of whether the cameraman is near the minister or batsman is near the minister. When we have a compound sentence, uh, again the anaphora resolution comes into play. What does he refer to? Just like in the complex sentence, but there are two sentences which are linked by a conjunction and. The cameraman shot the batsman, sentence number one, and sentence number two, he was happy. So how to deal with this? Again, we can deal with this with the construct of S bar, okay, and this WH and CC, these kind of constructs. So we will see how to build more complex bar structure out of this. So the summary of this part is the following. The summary of this part is that there is a phenomenon called attachment. Attachment becomes inevitable when we have to deal with longer sentences. The decision problem that comes in is to find out the attachment point. Okay, the clause attaches to which word in the sentence. The preposition phrase attaches to which word in the sentence. So this becomes a decision problem. And that decision is made by looking at the context of the word, context of the different words, and that context can be large. It can be intra-sentence or inter-sentence. It may go out of the sentence or it may remain, the control may remain within the sentence. And that decision is made based on many clues in the context. Those clues are the features which is aggregated by a classifier to make the decision. Okay, so be clear about this linkage between language and learning, linguistics and machine learning. We need to make decision. The decision is made by a classifier. The classifier makes use of different features or properties existing in the sentence and outside the sentence. We are coming close to our discussion and question answer and so on. But let me proceed a little more and bring in another kind of parsing which is called dependency parsing. And here let me give you a kind of demo. So take a look at this screen. This is called the LN NLP, which has now made it quite a name for itself by providing many different kinds of NLP tools and resources. So please verify that you're looking at the screen called LNNLP. LNNLP.
Yes, sir.
Yeah, okay. So it provides tool for named entity recognition, open information extraction, sentiment analysis, dependency parsing, constituency parsing, semantic role labeling, co-reference resolution, wiki table question answering, Cornell NLP semantic parser, text to SQL, converting natural language query to SQL, which is like a relational database query, has textual entailment, language modeling, masked language modeling, which is used in BART, for example. So many things have been done in this umbrella of NLP, which is now a pretty useful platform for natural language processing. The earlier, or let's say still existing natural language processing platform, very useful, is Stanford Natural Language Processing Platform, NLTK platform. So many of these things appear in your reference list and also on the website. So let me particularly take one tool, which is dependency parsing. I would like to introduce a different kind of parsing process now, which is not built in terms of phrases, but in terms of dependency between head and modifier. Okay, so let's take the dependency parsing and let me give the sentence. The cameraman shot the batsman. Okay, not when he was near the minister. That will do a little later. Now I press run. This sentence is being processed. It is processed. Okay. So first thing we have is the cameraman. Look at this large rectangle with the word shot. So the main verb in the sentence is the cameraman shot the batsman. How do I know shot is the main verb? Part of speech tagging. Okay, part of speech tagging has been accurately done. So I know shot is a verb and only verb in the sentence. So this has to be the main verb. So shot is the main verb. It has n subj relationship with cameraman. But you see, cameraman also has an internal structure, just like in constituency parsing. Cameraman has the internal structure of NN and DET. Okay, so the is DET determiner, cameraman is noun, and they are linked with a relation called NN. Okay, see that NN is not going to the, it is linking the two entities, the and noun. Okay, so this has an internal structure. Now the main relationship here is N sub, shot, and the cameraman. So shot is a verb which is told to us. Shot has a relationship called DEP with the batsman. The batsman has an internal structure, noun and DEP. Okay, so if you have the question in the earlier case, cameraman, there is no DEP. I have NN, but here I have a DEP. The batsmen are linked with DEP, and here it is linked with NN. Why is it so? Okay, we'll come to that. Okay. And then the whole sentence is done. You have the punctuation dot here. So the cameraman shot the batsman. The structure is this. N subj is a dependency relationship. The verb is shot. It has a relationship called DEP with batsman, and batsman and the again has a DEP relationship. So this is a very shallow relationship. It is just saying that shot has dependency with the batsman as a structure, and batsman and the have dependencies. The cameraman has a dependency with shot, but the dependency is now more precise. It is N subj. Okay, so this is the structure that is given here. Now let us make the sentence a little longer. Shot the batsman when he was near the minister, and we run it. Now the structure should be a little more complex. So the cameraman is linked with N subj with shot. Shot has dependency with the batsman. Shot has dependency with he was near the minister, but it has an adverbial modifier. Okay, when he was near the minister. So the verb has dependency with the batsman, has an adverbial modifier when, and a dependency with the whole sentence. He was near the minister. Okay, so notice that it is no longer in the form of phrases and sub-phrases, but it is in the form of dependencies. And one side of the dependency is called head, the other side is called modifier. Okay, head and modifier. So short E is the head, cameraman is the modifier linked by n subj. Okay, so we'll develop further this theory of dependency parsing, but machine learning and probability will not leave us, which is why we will also develop the theory of probabilistic parsing. uh, you have seen algorithmic parsing, but the theory of probabilistic parsing is something we will now develop further. Just a minute. Probabilistic parsing, and we are interested in the probability of the parse. So the probability of the parse is obtained by multiplying the probabilities of the grammatical rules. So dependency parsing, constituency parsing, rule of proximity, they will go on, but at the same time, because of the uncertainty, because of the need for using features within the sentence, outside the sentence, we need to classify. The classification is probabilistic, so we need to look at probability all the time. Okay, linguistics and probability both. So at this point of time, I will stop, and I'll take questions after a little while. But Diptesh, you can give a summary of what you saw in the demonstrations yesterday of the assignments.
Okay, so mostly for all the groups, this is a common feedback that your knowledge of HL was very good, and most of you had implemented all the three systems except for the fact that some teams had not implemented SVM or BiLSTM at all, and there were at least five teams, four in my group and one in group one, where they had not implemented SVM from scratch. So they had used linear SVC or the sklearn library. Everybody had reported the per pause accuracy and the confusion matrix, but I have something to add here. When you display your confusion matrices in a slide, we would appreciate if you use a graphical visualization like a heat map. Some of you had done it, some of you had not. That's okay, but from the next time onwards, please try and do that. Most of the teams had divided the work into one algorithm per person or one implementation per person, and there was not much overlap in this work besides the specific contribution of all three of the team members, where there were two team members only. You had divided the work amongst yourselves and done all the three implementations. And about the error analysis, there were some questions that what do the TAs or the course instructor uh, expect from you when the error analysis is supposed to be performed. So I think we had made it abundantly clear that we expect you to look at the individual cases and the output of your implementations and then come back to us and say why this particular word was misclassified or mistagged by the boss tagger. Some of you had done it and there was some really good error analysis. I would like to point out the team numbers from my group, specifically team 14, 17, 18 and 19. I'm not taking any names here, but you teams, you know your team IDs. So these guys had performed some really good error analysis with the individual component as well and with the per pause accuracies as well. So two different teams I would really like to appreciate. They had tried out byte pair encodings and fast text as well. And one of the teams I would like to appreciate for performing the feature engineering and showing the feature importance as well. Now, for the teams where the restructuring was done late or a new member was added at the last minute because people kept dropping the course, and there were some people who said that, you know what, we are probably not well, and they came back to the TAs very late saying that we need to be added to a team. We have sort of given all of you a team now. You have been restructured. From the next evaluation onwards, we expect you to please collaborate with your team members in a proper fashion. and then complete the rest of the assignments. Again, from one of the team, there was a complaint from a few teams that one particular team member did not contribute anything to the assignment. We request all of you to please again collaborate with each other properly and contribute something to the assignment. Don't make others work where all of you are going to be marked in a common fashion. Of course, there is the individual viva as well, but that is probably not going to, give us that sort of a separation, and we would like to, be lenient with the marking. But please contribute enough towards the team so that your team members do not feel the fact that they have to work solo. Okay. uh, about the fact that some of the teams were not able to implement SVM or BiLSTM or HMM for that matter, or either the two of these implementations or all three of them. The reasons were either the team structuring being done late, or two of the members dropping the course and new members being introduced to your team. It's okay. This is not a hard deadline we are following. You will be evaluated in the next evaluation, whenever the next evaluation happens for this assignment as well. So maybe you can complete the remaining portion of this assignment or this assignment by the next evaluation and just show us the results in the next evaluation. One of the team members said apparently that they were busy with the placement process. I don't think that's a very valid reason for not completing your assignment or not contributing to the team in particular for the assignment. But I would defer to the course instructor's opinion on this matter. So that's the complete evaluation feedback from the TAs. Thank you, sir. Thank you so much.
Yeah, so all of you should know that there is a large number of evaluation to be performed. I think there were about 40 groups, and each with 3 students talking to 120 students about. So this is a long and large task. Okay, so you should really do a good job of these assignments. And as I tell you all the time, NLP cannot be done without implementation. Okay? Otherwise, you'll be talking in the air and you will be only theorizing things. You have to burn your finger looking at the corpus, working with words, working with phrases, sentences, paragraphs, looking at pronouns, nouns, looking at the attachment, looking at part of speech, named entity, features, then parameter setting, probability, all this is together. NLP is a complete subject, okay? It requires a multifaceted view of a discipline. Everything is there, right? You need logic, you need probability, you need machine learning, you need deep learning, you need sigmoid function, you need softmax function, you need S-bar theory, prepositions, pronouns, everything is together. It's a beautiful combination of many things coming together, making a phenomenon called language. Language, after all, is the sign of our intelligence, and it sets human beings apart from animals. So who said this is going to be a simple trivial task? Cannot be. Okay, languages evolved after maybe 50,000, 60,000 years through evolution. You will be surprised to see the amount of resilience that is there in language. Have you ever thought about why uh, English uses S in the third person singular number present tense? Ram likes milk. Ram and Sham like milk, not likes. Why? Have you thought about this? This is again because of evolution. Just like by evolution, human beings arrived on Earth through many species slowly. So language evolution is also a very interesting topic. Okay, why English uses that S form? Why plural uses an S form, ES form? Why does it do so? Okay, there are languages where plural is not indicated by S but with reduplication. In Indonesian language, for example, if you want to say many books, you say book. I read many books in English is I read book in English, in Indonesian. Okay, so why does it happen? Why language takes different path in different places of the world. It's a very interesting study. And if you want to capture this in a machine, you better be prepared with many theories, including philosophy, physics, quantum mechanics, probability, logic, many things, algorithms, data structures, many things. Okay, so that's why it is a very, very complete discipline. Now, that said, there is a very large number of students in the class, large number of groups to be evaluated. Please do a good job. Allocate time systematically so that you show progress every week or every 2 weeks we are going to meet. And I'm very happy to know I was very busy with some kind of confidential work here, so I could not attend all the presentations by you. But from next time onwards, I think I'll be able to look at all the presentations. And I'm happy to know that you people have a good grip on the subject now, at least on part of speech tagging. And if you understand part of speech tagging, believe me, you will be able to understand all subsequent topics in NLP. Okay, linking it this way. I see that there are questions. Can we say who lives in Delhi is S bar? Not really. We'll have discussion on this. I think Diptesh, there are three questions, right?
Sir, may I please go ahead and say the question, sir?
Yeah, yeah.
Okay, so Ankita has a question that is there a possibility of two path lengths in the constituency parse tree being the same? If so, how is the decision made to resolve this ambiguity?
You cannot resolve this ambiguity with path length. You need additional features. So path length is one feature going to a machine learning classifier, but there will be additional features. So let me take a good example, but I also leave it to you to construct an example where this will happen. The path length will be same with respect to attachment. Next.
The next question is something that you already read. Can by Saurav, can we say that who lives in Delhi is S bar?
Grammarians don't do this. Again, we'll take this up as we go forward.
Okay. Jalai asks, in the example, I saw the boy with the telescope. You applied rule of proximity of PP to verb saw in one tree and noun boy in the other tree. Shouldn't we apply the rule of proximity only to nouns in PP?
So, rule of proximity typically is applied to lexical elements, okay, not to grammatical elements. So, I want to know the whole preposition phrase, so that's why I take PP. I want to resolve the question for PP. Okay, so PP should be attached to which point in the sentence, and the point is indicated by the word. Okay, not really attached to a phrase. Okay, it is typically for a point in the sentence. Therefore, we take the words saw and boy, but it will become more clear as we go ahead.
The final
Next.
question by Kaveri is, what if the context of sentence is very far away from the sentence? How do we extract the features that there?
Yeah, so by context, I think you mean the disambiguation clue. What if the disambiguation clue of this sentence is very far from the sentence? So this arises many times in word sense disambiguation, arises, for example, in agreement. Okay, when there is a long distance, the parse tree brings them closer. Okay, the tree distance is typically more typically shorter than the linear sentential distance. Okay, so we'll have to make use of these in the future. So all the questions today are forward looking. Okay, I'm happy to say that all the questions today require more discussions and more material to be covered. So I have partially answered, they will be answered completely as we go forward. Okay, okay, thank you.
Thank you, sir. Thank you so much.